Here we have a problem on derivative. Okay, let's go over the question. Use the limit definition of derivative to find f prime of x if f of x equals to square root of 2x and negative 1. Okay, first let me write the formula for limit definition of derivative. Here we have the formula for limit definition of derivative. Okay, to use the limit definition of derivative to find derivative of our the given function. So first we have to get the stuff which is equal to f of x positive h. Already we know that f of x equals to square root of 2x negative 1. So to get the stuff which is equal to f of x positive h, the given function, this x has to be replaced by x positive h. And the right side also the same thing. This x has to be replaced by x positive h. And then we have to plug in this square root of 2x negative 1 for this f of x. And we have to simplify. Okay, let me continue. So f prime of x equals to limit h tends to 0. And so we know that f of x equal to square root of 2x negative 1. And for f of x positive h, I have to replace this x by x positive h. Then I get square root of 2 times x positive h negative 1 negative. For this f of x, already we know that square root of 2x negative 1. So we can plug in square root of 2x negative 1 over h. Okay, now, so what I need to do is I have to plug in h is equal to 0 into this function. If I plug in h is equal to 0, the given limit for h, that is 0 for h, what will happen? So when I plug in h is equal to 0 over here, this will become just this will become just x. So 2 times x will become just 2x. So I'm getting square root of 2x negative 1 here. And here it will come as it is because we don't find h over here, square root of 2x negative 1. So over here we find h. When I plug in the given limit for h, that is 0. Okay, so here I subtract the two equal steps, that is square root of 2x 91, square root of 2x 91. So it will become 0. So I get 0 over 0 when I plug in the limit 0 for h into this function. Actually, whenever I get a result 0 over 0, it is called indeterminate form. When I evaluate a limit, if I get indeterminate form, it's not a final answer. We should not consider this a final answer. So what we need to do is we have to apply L'Hopital's rule in this step. Otherwise, we should try to simplify the function over here. Okay, now let's try to simplify. Instead of using L'Hopital's rule, better we can try to simplify the function over here. Actually, in this function, we find radical in numerator. So whenever I want to simplify a function like this, which contains the radical in numerator, so what I need to do is I have to take the conjugate of the part which contains radical. What is conjugate? So to get conjugate of this part, so I have to write the same terms over here and here. The only change what I have to make is I have to change the sign at the middle. So here we have negative at the middle. So when I change this negative to positive, so that is the conjugate of this expression. So now conjugate of this expression has to be multiplied both numerator and denominator. So this is the type of simplification when we have a function like this. Okay, now let me continue in the next step. So f prime of x equals to limit h tends to 0, square root of 2 times x positive h negative 1 negative square root of 2x negative 1 over h. So now what I'm going to do is I'm going to take conjugate of this one. I'm going to multiply both numerator and denominator by that conjugate. That is square root of 2 times x positive h negative 1 positive 1 square root of 2x negative 1. So I have written the same terms over here and here. So what I did is I changed the sign at the middle, that is negative to positive. So this is the conjugate of this one. So the denominator also has to be multiplied by the same conjugate, that is square root of 2 times x positive h negative 1 positive square root of 2x negative 1. Okay, now let me continue. F prime of x is equal to limit h tends to 0. Okay, here when I look at the stuff over here, I have the product of two binomials with the same terms. The whatever term over here, the same term here, and here we have square root of 2x negative 1. Here also we have square root of 2x negative 1. Actually, the product of these two binomials is in the form of one of the basic algebraic identity. That is, it is in the form of a negative b times a positive b. Here in these two binomials, we have the same terms, but here we have negative, here we have positive. So whenever I multiply two binomials like this, the product is equal to a square negative b square. Okay, so now the two binomials over here are in the form of a negative b times a positive b. Instead of a, we have square root of 2 times x positive h negative 1, and for b, we have square root of 2x negative 1. So we have to write the result of this product as a square negative b square, but instead of a, we have to write this, and for b, we have to write this. Okay, let me do it. So for a square, we have to write the first term here, that is square root of 2 times x positive h negative 1 the whole square negative For b square, we have to take the second term, that is square root of 2x negative 1, the whole square over, and we have to multiply the two denominators over here. Then I'll be getting h times square root of 2 times x positive h negative 1 positive square root of 2x negative 1. Okay, here this square root and square will cancel out. The same thing, the square root and square will cancel out over here. Okay, now let me continue the step over here. F prime of x equals to limit h tends to 0, and here the square root and square are cancelled. So we have 2 times x positive h negative 1 negative of 2x negative 1, because here we have just 2x negative 1, and divided by h times square root of 2 times x positive h negative 1 positive square root of 2x negative 1. Okay, so f prime of x equals to limit h tends to 0, and we can distribute this 2 to x and h. Then I'll be getting 2x positive 2h negative 1, and I can distribute the negative sign to this 2x and negative 1. I'll be getting negative 2x positive 1 over h times square root of 2 times x positive h negative 1 positive square root of 2x negative 1. So this positive 2x, negative 2x will cancel out. Negative 1, positive 1 will cancel out. I get f prime of x equals to limit h tends to 0. And we have 2h, just 2h in numerator. And denominator, we have h times square root of 2 times x positive h negative 1 positive square root of 2x negative 1. So this h and h will cancel out. Okay, so now next step, what we can do is that's all the simplification we can do. Now we can plug in the limit 0 for h. So we just have 2 in numerator, and in denominator, when I plug in the limit 0 for h, it will become x positive 0, that is, it will become just x. That is, we have square root of 2x negative 1 positive square root of 2x negative 1. Okay, so 2 over, when I combine this one and this one, both of them are like terms, square root of 2x negative 1, square root of 2x negative 1. So this is just similar to a positive a. When I have a positive a, what will I do? I will write 2a. So for this one, what I should write is 2 times square root of 2x negative 1. So this 2 will cancel out. Finally, f prime of x equals to 1 over square root of 2x negative 1. So this is the derivative of the given function.